Welcome to my video. In this video we're going to look at sequencing, selection and looping for programming in AQA's GCSE in computer science. Sequencing completes a series of actions in a specific order. Selection asks a question and the answer determines the path the program will take. Loops also ask a question, but it asks them over and over again until a condition is met. Let's start by taking a look at sequencing. It's basically a set of actions completed in a specific order. The first action would be performed. If there was a second action, then this would be performed, and same if there was a third. This would continue until all of the actions within the sequence were complete. An example of a sequence could be your morning routine. You first might wake up. You might then brush your teeth, and then have some breakfast, and maybe followed by a shower. Your morning routine may be different to this example. You might, for example, have a shower before having your breakfast. However, you are still doing it in a specific order, so therefore you are still sequencing. Let's take a look at an example of sequencing within a program. Sequencing is where there is no if statements, while loops or for loops within that particular part of the code. The instructions are simply executed one after the other. Here we start on import random and we execute this instruction. The program would then move to line 4 as this is the next instruction, and it would assign the variable num of toast the value of 3. It would continue through the program, line after line, completing each instruction. Once it gets to the end, this indicates the end of the sequence. Selections are different from sequences. They don't follow any specific order of events. They ask a question and the result of this question determines the path the program will take. In this example here, I've asked the person using the program, is it a weekday? And I'm expecting them to reply either yes or no. If they replied yes, it would go down outcome 1. If they replied no, it would go down outcome 2. And here you could see, if we related this to a real world scenario, such as school, in a weekday, you'd put on your school uniform. On a weekend, you'd put on casual clothes. You can see how the program, the selection, is allowing us to branch depending on the answer to that condition. Here is an example of a selection. The easiest way to tell this is because it has an if statement in it. That's a good tactic to remember for your exam. We're going to start out by taking in a user input. For this user input, I'm going to reply with Y to indicate yes, it's a weekday. The program would then move down to line 6, and this would be the start of the condition. It would be checking whether or not weekday is equal to Y. If it is, it would go within line 7 and run, put on your school uniform. If it's not, it would go down to the else and then go inside and print out put on your casual clothes on line 9. Basically, the way it works is on line 6 here, it checks if this condition is true or false, and this will determine the branch that the program will take. If I was to run the program again and take an input of no this time, when it gets to the conditional statement here, well in fact this time n is not equal to y, so therefore the result would be false, so the program would take a different branch. It would in fact print out put on casual clothes. In this example, you can see the program now has an if statement, an else if statement as an alternative, and an else if neither of these are true. By adding the additional conditions, this means the program now has more branches. In fact, it's moved from 2 branches in the original example to 3, which means the program has a larger number of paths it can take. I have added the need to enter a temperature on line 2. So then now when you look at line 9, if it's not a weekday and the temperature is greater than 28 degrees, it now advises you to put on summer clothes. The third programming construct you'll need to know is a loop. A loop is sometimes referred to as iteration. A loop is similar to selection in the fact it asks a question, but the key difference is it asks the same question over and over again until a certain condition is met. A good example of that would be using yourself, such as, are you hungry? If you're hungry, you eat. You'd then say, am I still hungry? Well yes, so you'd still eat. And this would go on and on and on and on until the condition is met, when you're no longer hungry. Now loops can be what's called infinite. Now the word infinite means forever. An infinite loop is where basically the condition is never met. So if I said something like, while 1 is less than 100, well 1's always going to be less than 100. So if I said while 1 is less than 100, print out hello, well the program would continually print out hello because 1 is always going to be less than 100. So why do we use loops? Well, loops allow us to efficiently repeat code. it stops us having to write out the same piece of code over and over again. So if we take a look at this list here, in my list I've got cereal, bread and milk. Now imagine that list was 80 items long or even 1,000 items long. Without a loop I'd literally have to write print and each of those items' names and print them out. It would take a long time. Whereas with a loop I can make the program loop round until it's printed them all out for me. So let's take a look at an example. It would come down to here and this says for X in foods, and that basically means for each item in the list foods. So the first item is cereal, so it would come down and it would print that out. It would then come back round the loop, and this time it's moved across to the next item, which is bread, and it would come down and it would print that out. And it would go round the loop once more, and it would come across to milk, and it would come down and it would print out milk. Okay? Now this is called a for loop, and the big advantage of a for loop is you use it when you know how many iterations you've got. Okay? How many times it's going to go around the loop. Now I knew it was going to go around 3 times because I've got 3 items. Okay? Well, that's called a counter-controlled loop because I know how many times it's going to happen. Okay? You can see here, look, now it's been round 3 times. When it comes back up, look, it notices there's nothing left in the list. So literally the program will just jump to here because the loop has completed. There's also another type of loop that we need to learn about called the for loop. Now the for loop is used when we don't know how many times the program is going to iterate. It normally has a variable inside of it that indicates when the iteration is going to end. Let's have a look at an example of that. Here I have a variable called hungry and it's set to yes. Here's my while loop. While hungry equals yes, well, I'm going to eat. Okay, I'm then going to check if I'm still hungry. If I'm still hungry, it'll come back round the loop, okay, and I'll eat once more. It will then check if I'm hungry again. The variable, I've set it again to yes because I'm still hungry. So it comes back round, it checks if it's equal to yes, and I'm still eating. Okay, it comes back round for a 3rd time, and I'm still hungry. So it comes round again, and it prints out eating. Now this time, the variable has changed to no because I'm no longer hungry. So when it comes back round, it checks if hungry is equal to yes, which it doesn't, which indicates the end of the while loop. So it jumps out of the loop and comes down to printing out, okay, you must be full. Now you can see there how the variable controlled whether or not that condition was true or false, which made the loop continue until the variable was no longer equal to yes. This is why while loops are also sometimes called conditional controlled loops. That brings me to the end of sequencing, selection and loops. Thank you for watching. Please feel free to contact me on this channel if you have any questions.